Welcome to the IBDP subject choices. This is for exams as from November 2025, since this is based on the newly published guides from the International Baccalaureate. So, Group 4 subjects being offered at LBIS International School are currently Biology, Chemistry, Physics, ESS, and also Design, which is offered by the Design Department. And our Science Department takes the responsibility to teach Biology, Chemistry, and Physics at SL and HL level. And if ever a student is going to do Biochem Physics or Design, at this stage they are currently using ESS at SL level to behave as the Group 4 subject as well. If ever you intend to do two sciences, well, you may do so by not choosing a Group 6 subject which form parts of the arts. What is very important when you choose your subjects is to know your prerequisites. The prerequisites are defined by the department, are defined and finalized by the DP coordinator. So always verify the latest publication from the DP coordinator to confirm the prerequisites, which you can also discuss with the DP coordinator if ever you have any doubt. So the prerequisites are as follows. So any IGCSE student, if you intend to do biology at HL, we are asking for a minimum C in biology extended, but if ever in SL, you will require a minimum D in biology core or an E in biology extended. MYP student, likewise, minimum 4 in biology if you're intending to do it at HL level, and at SL level, minimum 2 in biology. Likewise, chemistry has its own prerequisites, which are published on screen. Please pay attention that there is also a maths requirement attached to doing chemistry. If you do not meet the prerequisites in maths, you are not going to be able to do chemistry in Form 6, or if ever there are any possible conditional offers that have been offered to you. But if you do not have the prerequisites, you're most likely not going to sit for the subject. Moving on to physics, we have to pay attention that at HL level, you do require ADMATS at IGCSE or extended maths at MYP. Once again, these prerequisites have to be confirmed by the publication set out by the DP coordinator at the stage of subject choices. So today I'm going to speak about Chem, Physics, Bio. And these subjects actually have shared objectives. So the first aim of the Group 4 subject in the form of chemistry, physics, and bio is to develop a conceptual understanding that allows connections to be made between different areas of the subject and to other science subjects. The new guide is based on concepts, which all students of Le Bocage have seen in their MYP programs. And concepts, well, you transfer them. So any topic you learn in DP Sciences, there is most likely a link to another one, and this is how you build the bigger picture. Of course, as you study over the next 2 years, well, you will be learning new concepts, obtain new knowledge, understand the different methods, tools, and techniques that build sciences, that define sciences. All your sciences should help you to analyze, evaluate, and synthesize scientific information and claims. Okay, we've all watched this Looney Tune cartoon. I hope we've all watched it. Well, we do know that the bird apparently never falls, but the coyote is always falling. And we know, scientifically speaking, both of them should be falling. Sciences should develop our ability to approach unfamiliar situations with creativity and resilience. Let's take a look at the recent pandemic. The vaccines were produced really fast. Why so? Because over years of study, over years of finding patterns, over years of testing multiple situations, allowed scientists to know how to efficiently develop a vaccine and to administer it. And this is one of the fastest responses we might have had in the medical uh, history, if I could say it. So let's take a look at the next aim, and this is to design and model solutions to local and global problems in a scientific context. You may feel that you are not doing it, but as a matter of fact, you will constantly apply your scientific knowledge gained through chem, physics, or bio into real world problems. You are going to be leaders of tomorrow. So your learning should help you understand the problems and should help you design solutions for those problems. And some solutions are actually simplistic in nature. This first picture you see on the top, that is one of the biggest deserts in the world, which is the Gobi Desert. And right now what China is doing is just reforesting those lands. In an attempt to tackle the issue of global warming, they are planting more and more trees, more and more shrubs, overcoming the issue of desertification, making more land arable, and solving problems such as food crisis, and trying to fight the issue of increasing amount of carbon dioxide in the atmosphere. The second picture, well, again, if many countries are engaged in deforestation, there should be a method to remove carbon dioxide. And once again, the simplistic chemistry, the simplistic physics you learn has been used to design those direct carbon dioxide capture devices, removes carbon dioxide from the atmosphere so as to fight the rising issue of increasing carbon dioxide level and hence fighting global warming. Now, also, sciences should allow you to develop an appreciation of the possibilities and limitations of sciences. When I was in your spot, when I was 16 years old, a prosthetic arm would not move. A prosthetic arm will not close its fingers. It all sounded very science fiction. Today, connection to nervous pathways have been done. Chem, physics, bio all together. Okay? Developing that prosthetic arm, helping so many amputees. Still at an initial stage, but it is happening. But then we need to also understand that there are limitations to sciences. We cannot go according to our cartoons and think that in a flash we would appear on Mars, because we are limited by the speed of light. We are limited by the tools around us. We are limited in terms of the technology around us. So, at some point, we have to realize there are things that might just be fiction, but there are multiple tasks that can be achieved through sciences. Within our school, you need to understand that you shall be able to develop your technology skill in a scientific context. You will be making use of multiple senses, you will be making use of multiple databases, you'll be able to use multiple data collectors just to model out different experiments, to be able to record data accurately, and to analyze and evaluate it through your multiple projects. Your technology skills will always grow, and you shall be exposed to more and more equipment that shall allow you to understand what can make science better. As scientists, will always emphasize on the ability to communicate and collaborate effectively, and you should be able to do so for the collaborative science project and also other tasks you will be doing in your classes. We always need to understand the implication of sciences on the society around us, on the economy around us, what could be a cultural impact of it, and whatever we are doing should be within the line of ethics as defined by the IB. Of course, at the end of 2 years of study, you are going to be assessed. Assessed on what? Well, you should be able to demonstrate knowledge of the different terminologies, the different concepts you learn, the different skills and techniques you are going to display throughout these 2 years, and apply these skill, techniques, knowledge, concepts in a variety of situations. You'd also be analyzing, evaluating, and synthesizing multiple experiments. You will be collecting a lot of data, primary or secondary, verifying for their credibility, and using all those collected data, you are going to analyze trends, you're going to find patterns, you're going to try to make predictions. You are going to become our next scientist to this world. Of course, you will need to demonstrate the application of skills, and you should be able to carry out insightful and ethical investigations. What you have in front of you is an assessment outline for standard level, whether it be chem, physics, or bio. You have on the right column the weightage of the components. So you see that 80% is externally assessed through 3 hours of rigorous examination. And you also have a 20% worth internal assessment, which is your scientific investigation. So your teacher is going to moderate this internal assessment, and of course IB will verify whatever the teacher and you have been doing. So in terms of external assessment, your first paper, section A, is multiple choices, and section B are database questions, whereas paper 2 is what you tend to know as a theory paper. There would be a short answer and extended response question. The assessment outline for HL is similar, except that the external assessment is 4 hours and 30 minutes, but in paper 1 you still have MCQ and database question, paper 2 you still have short answer and extended response, and your internal assessment, still worth 20%, is your scientific investigation. So let's really understand what we are going to do in the SL program. I'm going to get into the HL program in a few minutes. The format is fairly the same in chem, physics, and bio. You need to understand that out of 150 hours, 110 hours will go towards what you know as the syllabus content, where you will basically be exploring your scientific concepts. You are going to apply them in a variety of scenarios, and is mainly the part that goes into the external assessment. 40 hours will be towards your practical activities. 20 hours will be practical activities your teachers will be assigning to you. So if 20 hours are being assigned by the teacher, so where are the remaining 20 hours? Well, 10 hours go to the collaborative science project, where all students of the group 4 subject will participate. So whether you do only design or only chem or only physics or only bio, you will participate, and you will have 100-word reflection to write at the end of it. If ever you do 2 sciences, or you do physics design, chem ESS, well, you have to do only 1 collaborative science project, and the reflection will be the same in both subjects. Then, of course, 10 of those remaining hours will go towards your scientific investigation. Depending on what you choose to do, it could be an individual project or it could be a collaborative project, but you all have to write individual reports of 3,000 words limit. HL program is no different. So what we have in front of us is 180 hours of syllabus content, 60 hours of practical content. And similarly, 40 hours will be assigned by your teacher, 10 hours goes towards the collaborative science project, and 10 hours towards your scientific investigation. What you have in front of you is the syllabus outline. So as you can see, for physics, you will have 5 concepts, which would be space-time and motion, particulate nature of matter, wave behavior, fields, nuclear and quantum physics. Of course, you also have the experimental program, which was explained to you a while back. So, the topics that you will have for physics under the first concept, well, you can see you have kinematics, forces, momentum, work, energy, power, mechanics. So many of those topics you may have encountered in your IGCSE or MYP program. Of course, even more advanced as we go along. So if you want to take a look at the topic list, please feel free, take a pause on the video, go through them. So, of course, why do I put a picture of a winch? Why do I put a picture of a black hole? Well, basically, many students, they design their project. You tend to have projectile motion. They investigate a range of variables, a range of possibilities. They verify whether their hypotheses are correct or not, or they may resort to database questions. So moving on for biology syllabus outline, well, you have 4 particular concepts. So unity and diversity, form and function, interaction and interdependence, continuity and change. Well, you can see that in biology, these themes, well, they could be explored at different levels. So either molecular level, cellular level, organism, or ecosystems. You may pause the screen to take a look at the different topics. Once again, many of them done at IGCSE or MYP, but being done at an even higher demanding level for IBDP. So even the next slide continues with further topics to be done in biology. Many students are currently performing ecological investigations. They are able to study ecosystems. They are able to perform experiments based on the foods they eat. I've seen students trying to extract DNA and trying to collect multiple information. In chemistry, you're going to study 2 concepts, structure and reactivity. So in terms of topics, you will see they are currently on screen. Again, similar topics you may have seen in Form 4, Form 5. Once again, we are going to explore them in even more details and trying to see the applications in the real world. In terms of objectives, in terms of skills that the science subjects will offer to you, they are similar. The aims are similar, as you have seen described throughout the whole recording. What you need to be able to do is decide, okay? So being able to decide which sciences to choose. Your teachers will be able to assist to your queries, trying to understand your strength, your weaknesses, whether you will adapt to those subjects or not. But remember, all your choices will impact your future. So what you need to ensure is that you take a look at which university you want to go. You take a look at the career you want to have. You explore those university websites, figure out the requirements from those university websites. Different universities may have different requirements. In certain situations, you may see that to do medicine, you might not even require biology. Okay? In certain, so you see, currently from University of Manchester, major subjects must include chemistry or biology. So let's say you didn't have bio, you most likely would have been able to go further. Let's say you didn't have chem, but you had other subject which could have helped you, you might have been admitted, you might be a student of Manchester. Okay, so same goes for civil engineering courses. So do remember, your subject choices should be more geared towards what you want to do in the future. Choosing sciences, I can tell you one thing for certain, will open multiple fields. So more science subjects you have on your side will open more possible fields. You may see yourself going for finances despite the fact you took 2 sciences in IBDP, simply because it keeps the option open. A finance course most likely is going to have very open requirements where any science student can easily go in. So with your critical analysis from sciences, easy to hop in most fields. Of course, if you want to be an interior designer, you know that maybe sciences are not necessarily going to contribute to what you want to do. Okay, so sciences might not always be the answer, but in many cases, sciences will keep an open door to most fields you might want to explore in the future. So consider taking sciences. It will be a stronger part to play in your future career. Do remember, whenever you have any queries, please reach out to the head of Department of Sciences, reach out to your science teachers. They have the appropriate information for you. If ever you have career question, please reach out to the career counselor, Mrs. Jandu Singh. She will guide you to how to look at prerequisites or requirements from universities to inform your subject choices. And please, please, please do not rely on your strongest subject to choose for your diploma subject, because simply doing that may affect your future career. It might not be in the direction you intend to take. So, correct decision making time, think well what you want to do, and choose your subjects. Thank you.